Hi everyone, my name is Jessica and my partner's name is Katharine. We are both biomedical engineering students and have collaborated with each other for our final project to create audio modulation effects using Matlab Simulink.
For this project, we built a series of audio effects in Simulink and also encoded the same effects in Matlab with an interactive GUI. The delay line effects we compared in this manner were echo, chorus, and two flanger variants. We also looked at the tremolo and vibrato effects. Unless stated otherwise, all of the demos and samples in this presentation were done using the provided sample guitar2.wave. The tremolo effect was very straightforward. It's basically amplitude modulation, and as long as the low frequency oscillators are the same, the outcome is pretty much identical in both methods. Similarly, the vibrato effect was really just frequency modulation, and only the shape, frequency, and amplitude of the low frequency oscillators really mattered. Here is the sample audio after the tremolo effect in Simulink.
Here is an example of our tremolo Matlab code for comparison.
And here is the sample audio after the vibrato effect in Simulink.
Here is an example of vibrato shown through Matlab code.
The Simulink chorus effect is actually a 2-in-1. The radio button changes the type of oscillator that controls the variable delay. The first uses a pair of sinusoids, and the second uses two distributions of randomly generated numbers to determine the time variant delay. The delay in either case doesn't exceed 25 milliseconds. The usual block diagram for a chorus effect, as shown on the left, is much simpler.
This is an example of the chorus effect using Matlab code.
Compared to the chorus effect on the previous slide, the flanger effect is deceptively simple. The difference equation is y of n equals x of n plus gain times x of n delayed by a function of n, such that the delay varies in magnitude sinusoidally. Rees and Zolzer both like 0.7 for flanger gain, and so that's what we used. Here is the Simulink model for the basic flanger and what the output file sounded like. And the flanger with feedback. The Simulink model for the flanger with feedback is less simple and briefly caused some problems as it attempted to crash my laptop.
This is an example of the flanger effect using Matlab code.
Some of the effects we looked at could be very subtle, especially in a busy signal like guitar2.wave. We encoded a frequency domain analyzer. It's essentially the first half of a phase vocoder plus a little extra. It lets us look at the highest magnitude peaks in the frequency spectra and find the instantaneous frequency at each of those peaks for every window we look at. We can input a wave file, a window length n, and the number of peaks p we are interested in, and find the p largest frequency components in the signal. This means we can look at the differences between very similar signals more closely. Here is an example of what this tool produces. The result can be like the graph on the left, which helps visualize harmonies and vibrato, and looks much nicer. However, the data is much more useful in the form of a matrix like we see on the right. Each row encompasses a window or a segment of the sample that's n long, and each column is one of the largest peaks. And here's some very quick thoughts on what we can do with this data.